Okay, bit of inequalities in. This is chapter 15 of our GCSE Maths. We should be very aware of all these signs and what they mean. They less than or equal to, greater than or equal to. Something like this, a wee double inequality, means that x is in between minus 10 and 8. It can be minus 10 because of the equal sign, but it can't be 8. So in between those. Inequalities can be displayed on a number line. Integer solutions, or the possible whole numbers which satisfy the inequality, they are represented by a solid dot. Represent the integer values of x greater than 2. So it means it has to be a whole number and it has to be bigger than 2. So our possible values then would be 3, 4, 5 and 6. Less than or equal to 3. So it can be 3. So we can have 3, 2, 1, 0, minus 1, and that's just a number line. Obviously that goes on forever in that direction. Real solutions, that's what says the word real solutions, include whole numbers, fractions and decimals. So if it's less than 3, it's all the numbers in between. So we can't do a dot. You'd be there forever doing all the dots, obviously. So we need to do a line instead. A line with a dot on the end is used to represent the real solutions. An open dot means it's not included. A solid dot means it is included. Again, this is stuff we've done before. So x is greater than 1. So because we can't start at 2 here, because 1.1 is going to be on it and stuff like that. So we do our circle like that. Then we do our line going along like that. So hopefully that makes sense. We can do a straighter line than me. Example 2, in between 1 and 5. So I would do my hollow circles to start with before we work out what we're doing. And let's join them up and then do some working out to see what we need. So here it can be 1, so we colour in the 1 here. It can't be 5, so we leave that then like that, not coloured in. Solving inequalities. Inequalities can be solved in the same way as we would. There's one extra rule we need to remember through. So the same way we would solve equations. So I'll set up both sides, do a thing the same both sides. Multiplying or dividing through by a negative number reverses the inequality. You can avoid this problem by always making them a variable term positive and solving inequalities. What does that mean? If we wanted to take 2 from both sides here and then divide by minus 3, the fact we're dividing through by a negative means we need to flip this sign so it turn around. I avoid that like the plague. So I would add 3x to both sides. That's my first move to make this term positive. So that gives me 2 is greater than 3x minus 10. Hopefully you're going to be a bit tidier than me here. Let's see if we can tidy this up. Want to get the x on its own, so I'm going to add 10 to both sides. 12 is greater than 3x. Divide both sides then by 3, and I'm going to get 4 is greater than x. Now I wouldn't give full marks for that. I want the final answer then. Hopefully you realise if 4 is greater than x, that means that x is less than 4. Second example, 2 upon 4x minus 1 is less than 18, so it's going to give us 8x plus 2 is less than 18. Going to take 2 from both sides. 8x is less than 16. Divide by 8, and I get x is less than 2. For this one, as ever, you save yourself hassle by getting rid of the smallest variable. So we have a 3x here over 8x here, so we want to take away 3x for both sides because it's the smallest one. Now it leaves the x on the wrong side, but that's okay, we can fix that at the end. So it's going to give us 4 greater than or equal to 5x minus 6. Add 6 to both sides. 10 greater than or equal to 5x. Divide both sides by 5. 2 greater than or equal to x. And final line then is going to be x less than or equal to 2. Double inequalities. You can do these a couple of different ways, but I tend to like to separate them out, and then we can get our answers then from there. So let's see what I mean by that. We're going to solve minus 4 is less than 3 minus 4x, and then we're going to solve 3 minus 4x is less than or equal to 9. So here, negative, so I'm going to add 4x to both sides. So that's going to give me 4x minus 4 is less than 3. Add 4 to both sides. 4x is less than 7. Divide by 4, it's all about the 4's here. And we get x is less than 7 over 4, or 1 3/4. Over on this side then, again we have a negative x, so add 4x to both sides. 3 is less than or equal to 9 plus 4x. Subtract 9 from both sides, minus 6 less than or equal to 4x. And divide both sides by 4. What does that give them? Minus 1.5 less than or equal to x. So x is greater than or equal to minus 1.5. So if x is less than 1 3/4 and greater than or equal to minus 1.5, the nicest way to write this is minus 1.5 here, and then 1 3/4 here. Hope that makes sense. So x has to be in between minus 1.5 and 1 3/4. It can be minus 1.5, but it can't be 1 3/4. Similarly then for this, we're going to have, it's going to be a bit of work then for this one too. Less than 5 minus 3x. Let's not get this confused in the question. And the other one we're going to do, so I've taken these two bits of the inequality here, and then I'm going to take these two bits. So it's going to be 5 minus 3x is less than x minus 6. So what am I doing here? I am going to add 3x to both sides. That gives me 3x plus 4 is less than 5. Subtract 4. 3x is less than 1. Divide by 3. And I get x is less than 1/3. Over on this side, get rid of your smallest value of x. So that's my minus 3x. So I'm going to add 3x to both sides. 5 is less than 4x minus 6. Adding 6 to both sides. 11 is less than 4x. Dividing by 4. 11 over 4 is less than x. That gives me x is greater than 11 over 4. This one's always a bit controversial. If x is less than 1/3 and x is greater than 11 over 4, I don't think there are any solutions to that. I don't think there's a number you can put into this end to kind of make it work. But the jury's out on that at that stage. You won't get a question like this in the exam because it's too controversial for that sort of thing. Example 6, the length of a rectangle is 3 centimeters less than the width. If the perimeter is less than 40 centimeters, find the range of possible values for the length. So let's draw a wee rectangle here. I don't like a width being smaller, but that's okay. The length of a rectangle, so if we say the width is x, then this is going to be x minus 3. And the perimeter has to be less than 40. So what are we saying here? We're saying x plus x plus x minus 3 plus x minus 3 has to be less than 40. 4x minus 6 has to be less than 40. Adding 6 to both sides. 4x has to be less than 46. X has to be less than many times 11.5. Now again, we need to be careful here. Let's see, so anything where x is less than 11.5, means that this is going to be less than 40. I would add another wee bit to this. Again, this is maybe beyond what you're expected to be able to do, but I think if you go anywhere lower than 3, then it's not going to work either, because you're going to have a negative value here. So if you have, x is 2, this is 2, this is 2, you can't have a length of -1. It doesn't make any sense to have that. So I think then that x has to be greater than 3 as well. So I'm going to add to the inequality. X is in between 3 and 11.5. Graphs of inequalities. These can be a wee bit of a hassle, but hopefully they're okay. Inequalities can be displayed graphically. When a line is drawn on a graph, it splits the graph into 2 regions. Points on one side of the line will satisfy the inequality, whilst points on the other side will not. We shade the side of the line which does not satisfy the inequality, leaving the side that does clear. For inequalities involving less than or greater than, we use a dashed line, as points do not satisfy the inequality. It's a bit like the circle filled in or not, only we're kind of in 2 dimensions now. For these, we use a solid line and do satisfy the inequality. Draw a graph to show the region which satisfies the inequality. X is greater than or equal to 2. The fact that it's greater than or equal to means that it's going to be a solid line, and so we want to effectively plot the line x equals 2. And I'll fill in a couple of numbers here, 2, 4, 6, 8. I hope you're ahead of me here and know what's going on. -2, -4, -6. But the line x equals 2 is going to be this one here. And so that's what we're looking. We're looking where x is greater than or equal to 2. So we want this bit here. Sometimes we do a big R in that. And then we got rid of the rest. Similar one then for number 2. It's x is in between 4 and 7. 2, 4, 6, 8. Let's go for 4, 8. We don't really need these numbers in, but that's okay. I think it helps a little bit so you can see. -4, that's a minus as well, obviously. -8. And so it's in between 4 and 7. The 4 one, so we have to plot the line x equals 4, and we've got to plot the line x equals 7. Again, those are vertical lines going here. Now this is the bit you need to remember. Solid line here, however, it's x going to be less than 7, so we want to do a dotted line for this one. If you can remember that, you're doing well. And the wee region is x has to be in between those 2 values. So this is our r here, and we get rid of anything else. So it ends up looking like that. Slightly tougher one here then. Draw a graph to show the region which satisfies the inequality. X plus 3y is greater than or equal to 6. Label the region R. So we need to plot the line x plus 3y equals 6. There are a couple of ways of plotting this line. Let's do a few of the numbers here so we can see. That's 4, that's 8, -4, -8, 4, 8, -4. Where was -4 there? 1, 2, 3, 4, -8. You could do y equals mx plus c. Let's maybe do that. Rearrange and give me 3y equals -x plus 6. Y equals -1/3 x plus 2. Now, do you know what that graph looks like? That crosses at 2 and has a gradient then of -1/3. So every time I go along a square, I go down 1/3. But if you wish, you were going to cross 3 down 1. Good practice for y equals mx plus c graphs, and then going on from there as well. Cross 3 at 1. And that's our line there. It's less than or equal to, so it's going to be a solid line. And there's a bit of controversy about how to do the rest of it, but if x plus 3y is going to be greater than or equal to 6, I very, very, very strongly suspect the bit we want is above it, because we're looking when x plus 3y is going to be that. In fact, I know it's going to be above it. But sometimes you want to go back to the inequality. and pick a number that's not, pick a coordinate, sorry, that's not on the line. So 1, 1 isn't on the line. Do you see the point 1, 1 there? So if I sub 1, 1 into this, 1 plus 4, is that true? That is not true. So this side we don't want, and we do want this side here. So what do you do? Let's talk us through it again. Ignore this symbol here, and we change it to an equal sign, and we plot this graph. Another way of plotting the graph is to put x equal to 0 and y equal to 0. You can give you kind of those 2 points there, and just do it like that. Some people like that method better. I tend to like the y equals mx plus c method better, and we can suss out then from there. Once you've done that, once you've plotted your line, make sure it's a dotted line or a solid line. This one's solid because it's greater than or equal to. Then pick a point not on the line. So I picked 1, 1. It's not on that line there. I put the x equals 1, y equals 1 into this, and I get 4 greater than or equal to 6. That's not true. That means anything in this side of the line is false. Anything in this side of the line then is true. Example 4 there, where are we going to plot this? There. That's okay. Let's see. Draw a graph to show the region which satisfies x greater than or equal to 2, y greater than or equal to x plus 3, and x plus y less than 12. Label the region R. So first of all, I want to do x equals 2. We're going to be a wee bit back and forward here, but the line x equals 2, I think we've done it. It's going to be a solid line, and it's greater than or equal to 2 is the bit that we want. So here's our graph. It's all filled in for us. Let's get a bigger ruler. So there's my the 2. Again, I mean, see, from this method, you can do that if you want. We can go, if we want, x greater than or equal to 2. Pick a point that's not on the line. 0, 0 is not on the line. If I put 0 in here, 0 greater than or equal to 2 is not true. So it means this side is false. Now, can you see most of this here? I think you can. And the bit we want then is on the right hand side. We're not going to do our R just yet because we need to do the other bits and pieces to see where we are from there. That was our first one. Our next one, remember, we get rid of the sign, so it's y equals x plus 3. We can plot that one straightforwardly enough. A gradient of 1 and crossing at 3. So it crosses at 3, and we go then across 1, up 1, across 1, up 1, across 1, up 1, and so on and so forth. Excuse me while I try and do as accurate. I think it's less than or equal to, isn't it? I might regret this if it doesn't work out, but I think it's a solid line. I'll check that in a second. I'll be doing some rubbing out if not. Yeah, we're good. It's greater than or equal to x plus 3. So we want to pick a point that's not on the line. Plenty to choose from. I'm just going to go from 0, 0 then again. It couldn't be easier. So we're going to go y is greater than or equal to, x plus 3. Pick a point not on the line. We are picking 0, 0. So y coordinate 0. Is 0 greater than or equal to 3? It is not. So the point 0, 0 is not in the right area. So we shade out that bit, and then we get rid of the other bit. So 0, 0 is no good to us. So anything on this side is no good to us. So what are we left with currently? We are left with, I'm a bit nervous about this now, but hopefully we'll be okay. We're left with this wee region here, so we need to see what the last one brings us. We'll maybe do it the other way. X plus y is less than 12. Remember, we get rid of the inequality sign, and we set it up then like that. So we're going to draw x plus y equals 12. I'm going to do this a different way. Of course, you can go y equals minus x plus 12 if greater than minus 1 crosses at 12. But you can actually get two nice easy coordinates from this and work from there. If I put x equal to 0 into this, 0 plus y, then I get y equals 12. That means that the point 0, 12 is on this line. If I put y equal to 0, x plus 0 equals 12, that means I get x equals 12. So it means the point 12, 0 is on the line. Of course, as I said, take the x over to this side, do y equals mx plus c, get a gradient of -1, y-intercept of 12, but I've just done it a slightly different way here. So we know the point 0, 12 is on, and we know 12, 0 is on. So we have this line here. Now, remember, it's a less than, so we've got to do a dotted line. Just joining these 2 points here. I hope you can see this as good as I can. So dotted line here. So there is a region. We need to work out if it's this bit then or this bit. So we're going to pick a point not on the line. So I'm going to go x plus y is less than 12. I mean, to me it's very obvious what we're going to go. 0, 0. 0 plus 0 is less than 12. That is definitely true. 0 is smaller than 12. So the point 0, 0 is on the right side of the line. Here's the line. Here's 0, 0. This is the correct side. So the side we want to get rid of is this side here. Now, this is starting to look a wee bit messy, but I hope you see the region we're left with. We're left with this wee bit here, and that's us finished. That's that bit done. All right. Reading inequalities from a graph, you should be able to state the inequalities which satisfy a region shown on a graph. Find the inequalities which define the region R. I'm struggling to see the region R here. I'm not sure which bit's been shaded. Goodness, I'm just going to pause here while we decide and work out what's going on. Okay, here is what I think has happened. I think the photocopy hasn't come out very well. I think this is all shaded. This is double shaded because of this bit here. And I think this bit here is all shaded. We have 3 solid lines here from what I can see. So we have this one, we have this one, and we have this one. So we need to find those inequalities. So let's start with this one here. That is the line y equals 0, and above it is true, so it must be y is greater than or equal to 0. This one here, that's a vertical line. Remember, these are the wrong way around. It's x equal, that's the line x equals 2, and we want the right hand side of it, so it must be x is greater than or equal to 2. And then finally, this line is a little bit tougher. So we have, let me see, it crosses at 6 and the gradient is -1. Can you see for every one you go along, you go down 1? So that's going to be the line y equals minus x plus 6. I'm going to rearrange that. If the way we've been doing these, that's normally written then as x plus y equals 6. And we want below it, can you see that the r bit is below that line? So that's then going to be x plus y is less than or equal to 6. So my 3 inequalities in that I want are x plus y less than or equal to 6, y is greater than or equal to 0, or x is greater than or equal to 2. Finally, maximum and minimum values for inequalities. You should be able to find the maximum and minimum values to satisfy a set of inequalities. The maximum or minimum will always be at a vertex of the region. Find the minimum value of x minus y for the region shown. So where is my region shown this time? Goodness. I think, what have we got shaded? I can't work out if this wee bit here is shaded or this bit here is shaded. I'm going to pretend, for the sake of things, that this is kind of what's shaded here. I'm also going to pretend that these are all dotted lines, because we haven't really dealt with dotted lines in a while, which means you're allowed on those actual points. So what do they mean by x minus y? And we're looking for a minimum, so we want the smallest number that x minus y can be. Let's pick some numbers that are on this wee triangle. Here's the point here, it's the point 1, 2. So 1, 2, that means x equals 1 and y equals 2. If I put that into here, 1 take away 2, I get minus 1. So it's going to be at a corner, I would have thought. Let's try this one here. That's the point 4, 2, isn't it? So there's 4, 2. What does that mean? That means x is 4, and that means y is 2. We are, so 4 take away 2 gives me 2. Okay, so that point's definitely better at the minute. And let's see this other corner, 1, 4. So that's the coordinate 1, 4. So that means x is 1 and y is 4. And it's going to be then 1 take away 4, that's minus 3. So finding the minimum value of x minus y for the reasons shown. So therefore my minimum value then is minus 3. Just a couple of notes about this. I can't see this. I guess I'm too old that I can't see if it's shaded or not. So I'm guessing that this bit here is shaded and we're dealing with this bit here. It might not be. It might be this is shaded, in which case the answer is going to be different. The other thing to be careful of is if they are solid lines, I've assumed they're dotted lines. If they're solid lines, you can't be on those points. So you've got to be kind of, other bits and pieces. But I think it gets easier then if you can have then the dotted lines and find out what it is you're looking for. But hopefully that makes a bit of sense.